Hey guys, Chavez. We have an extended spring break. Some of you guys are probably really happy right now, and some of you guys are probably really sad. Don't be scared. Hopefully, this coronavirus deal will pass. Um, I think you guys will be safe. I think we should be more concerned for our elderly people. So please take care of them, guys. So yeah, let's go ahead and get started, and let's rock and roll. So this is going to be the last notes after this. It's pretty much just problem solving and going over. After this, just a review. Hallelujah. Congratulations, guys. That was a clap, but it was a weak clap. So let's just get right into it, guys. A quick review here. So let's see. Example 1, x squared antiderivative from 1 to 3. So it's like area under the curve from 1 to 3. So antiderivative of x squared is x cubed over 3. I can do a little line because it's just one term there. Put a 1 and a 3. So that means 3 cubed over 3. Some of you might be tempted to cancel one of those 3's, but don't, because then I have this 1 to the third power, which is just 1 over 3. So 3 cubed is 27, minus 1 is 26. So 26 over 3, and no, it doesn't reduce. That's it. So that's it, guys. And yes, I'm aware that some of you guys don't have calculators. I don't think we'll need them. So example 2, you have 1 over x dx, and you're looking at it, and you're kind of be like, huh? If you haven't done calculus in a week, you're probably going to look at it and be like, what do you mean? What are you talking about? So remember when we did the derivative of ln of x? The derivative of ln of x is 1 over x, guys. So if I have 1 over x, the antiderivative must be ln x. Now, because my domain is positive, I don't have to put absolute value. Excuse me. I'm going to put a 2 in the bottom, 5 on the top, and I'm just going to do upper minus lower. So this is the same thing as saying ln of 5 minus ln of 2. Now, we can use properties of logs because ln's are kind of like exponentials. They're similar. So properties of log, guys, side note. So let me put the side note here. If you have ln of a minus ln of b, that's equivalent to a single ln of a over b. So some of you guys have been making a mistake. You did ln of a divided by ln of b. That is not correct. So we come back here and we say ln of 5 over 2. And there it is. That's it. And you can verify that. You can type that into the calculator and see that that is, in fact, correct there. All right. So here we go. Antiderivative of e to the 2x. Well, if you remember, the derivative of e to the u is just e to the u du dx. So antiderivative has to be e to the u. So let's see, e to the 2x. So antiderivative is going to be e to the 2x. Now, if I were to take the derivative of this, I would have a 2 in the front. I do not have a 2 in the front of that integral, guys. See? There's no 2 there. There's not in the. So in order for me to cancel that 2, I had to have a half. And I'm going to evaluate this from 2 to 5. Upper minus lower. I'm going to keep the half factored out. So I'm going to write e, and then 2 times 5 is 10. So e to the 10 minus, and then 2 times 2 is 4. E to the 4, no, there is no property. We're not going to put e to the 6th power or something like that. Leave it alone. I guess maybe you could factor out an e to the 4th, and then it'll be e to the 6 minus 1 or something like that. But no, I would leave it alone right there, guys. All right, let's go to the next one. 3 to the power x. No, do not do this. I've seen several of you do 3x plus 1 divided by x plus 1. That is wrong, guys. Please do not do that ever, ever, ever. Please, 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 please. If you remember, the dx of a to the u is a to the u ln a du dx. So, going backwards, the antiderivative of 3 to the x must be itself, 3 to the x. Now, if I were to take the derivative of 3 to the power x, I would have 3 to the power x ln of 3. You don't have an ln of 3, so that means I don't have an ln of 3 in front of this integrand here. That's what I'm talking about. So because I don't have an ln of 3, that means that I had to have 1 over ln of 3 like so. So you're doing the chain rule in reverse, guys. And this, I'm evaluating it from 2 to 5. Now, look, this is 1 over ln of 3 is just a constant. If I take the derivative of this, 3 to the power x, I guess I would write this in the front. 1 over ln of 3 times 3 to the power x times ln of 3. Well, 1 over ln of 3 times ln of 3 is just 1, which is, I would get this guy. See? It works. Chavez, I have no idea what you just said. I'm saying this, guys. If I were to write, do not write this down, just listen. 1 over ln of 3 times 3 to the power x, and I were to say take the derivative of this. Well, this is a constant. Leave it alone. Notice it's a product. I'm not putting a plus. If it was a plus, then the derivative of that constant will be 0. Leave that alone. 1 over ln of 3 times 3 to the power x. The derivative of that is, I'm doing this, and then ln of 3, which is this part. And look, 1 over ln of 3 times ln of 3, they cancel each other out, and you just get 3 to the power x, which is what I have right there. All right. Hopefully that made sense to you guys. If not, rewind it, or, go to the back. There's no such thing as rewind, right? Well, I guess there is. All right. I'm going to plug in a 5. I'll plug in a 2, but I'm going to factor out the 1 over ln of 3 because both terms are going to have that. 1 over ln of 3. And if I plug in a 5, I'm going to have 3 to the power 5 minus 3 to the power 2. And I'm going to leave it like that. And that's it. All right. This one's coming from Delta Math, guys, with a slight edit. I think originally on the Delta Math, sorry guys, I need to make sure that I'm recording here. On the Delta Math, I have the dx here. I don't like that. I put the dx here on the side. As long as you don't have the dx here in the front, because that'll be the worst case scenario. Remember, we're adding an infinite amount of rectangles, Riemann sums, width times height, or height times width, height times width. So put the dx here in the back. All right. So you can do u substitution if you want, u equals 4x minus 1, but I'm not going to bother with that, guys. As long as you have 4x minus 1, you have a linear, must be linear in the bottom, in denominator. And notice you have no terms in the top, nothing with no x's, no nothing, constant. It's going to be an ln. So this is going to be ln, put the 2 in here in the front, ln of 4x minus 1, and I would probably put absolute value, but my 1 and 7 will guarantee that the 4x minus 1 will always be positive, so I'm good right here. I'm going to put bracket, I'm going to put 1, I'm going to put 7. I'm going to do top minus bottom. Both terms are going to have a 2, so I'm going to leave the 2 on the outside, guys. And here we go. ln 7 times 4, 7, 14, 28, minus 1, 27. So ln 27 minus, let's see, 4 times 1 is 4, minus 1 is 3, minus ln 3. So now I can write this guy as 2 ln of 27 over 3. And I can write that as 2 ln 9. Recognize, that's not the only answer. Oh, that's the bell, guys. Oh, let's go to the next class. I'm kidding, guys. We can't, no one's here at school. I'm literally here by myself on this table. All right, anyways, recognize that 9 is 3 squared, and I can move that 2 to the front, and 2 times 2 is 4, guys. So this is the same thing as saying 4 ln of 3. Yes, this is correct here too. This is also correct as well. So they're all the same. You can actually also say ln of 3 to the power 4, but whatever. Easy? Yeah, I think it's easy. I think you guys understand. All right, now we get to some fun ones. So we have this, x squared minus 7x minus 11 over x minus 8. And at first glance, you're thinking, maybe I can do u sub. And if you make u equal to x squared minus 7x minus 11, du would be, if I were to, don't write this down, just listen. If u is x squared minus 7x minus 11, it doesn't make any sense because then du will be 2x minus 7 dx, and I don't have a 2 and a 7 there. And notice that will be in the denominator, it's not in the numerator, so you cannot do that. So the way to combat this, and listen up BC kids, because you guys are going to have this also. The way to combat this is you're going to have to do long division. Now, Delta Math does synthetic division. If you think that you're saving a lot of time doing it synthetic, go right ahead. When you were in 5th grade or 4th grade or 3rd grade, I don't know what grade it is that you learned divide by with remainders. When you had something like 82 divided by 9, that was the same thing as saying 9 and then writing 82, and then you would say, oh, okay, 9 times 9 is 81, and then you subtract, and then remainder 1. That was your remainder. And then you said 9 and 1/9. See? So that's what we're going to do. That's exactly what we're going to do. So I need to figure out, what I'm trying to do is make this easier. So I'm going to write, let me go put it in blue, guys, so we won't confuse it with the red stuff over there. X minus 8 on the bottom, x squared minus 7x minus 11. And I say x, this x right here, x times what gives me x squared? So what is that, guys? Yeah, it's x. Yeah, I can hear you guys. I'm kidding, I can't hear you guys. It's a recording, guys. X times x is x squared, so I write x squared down here. And then look, don't forget this 8, so you say this x up here, this x right here, times 8 equals 8x. So, well, negative 8x, because there's a negative there. So I put minus 8x. Now I'm going to subtract these. When I subtract, let's see, these x squares cancel out. And then that negative turns into a positive. So negative 7x plus 8x is just an x. So it's going to be x. And then I bring down the 11. So minus 11. And now you say x times what is x? Well, it's just 1. So I put a 1. And I put x. And then x times negative 8 is negative 8. And again, I'm going to subtract. So these cancel out. And then negative 11 plus 8, 9, 10, 11. That's a negative 3. That's my remainder. So I'm going to write minus 3 over x minus 8. And I guess I should have done it in blue. My bad, guys. So now this integral here turns to this. 2 to 6. And I'm going to write x plus 1 minus 3 over x minus 8 dx. Now let's see if it turned easier or not. It looks like it did turn easier, guys. I'm going to put an equal sign. Antiderivative of x is x squared over 2. Antiderivative of 1 is x. And then antiderivative of this guy right here, that's an ln. Put the 3 in the front. ln. Let's see, yeah, I'm going to have negative values with my domain, so put an absolute value. X minus 8, close it. And because I have more than one term, I'm going to put them in brackets. 2 in the bottom, 6 on the top. If I just had one term, I would put a little line. And there it is. I'm going to do upper minus lower. So I'm going to plug in a 6 first. So 6 squared is 36 divided by 2. I think that's 18. So I'm going to write 18 plus 6. And look, we're doing this without a calculator, guys. 6 minus 8 is negative 2. Absolute value of 2 is 2. So I'm going to write minus 3 ln of 2 minus, I used a parenthesis there, minus, now I'm doing the lower limit, 2 squared is 4, 4 divided by 2 is 2, plus 2, and then 2 minus 8 is negative 6, but it's absolute value, so I'm going to write minus 3 ln of 6. Okay, I'm going to distribute. Well, I'm going to combine like terms, really. So I'm going to combine these two first. That's a 4. I'm going to combine this. 18 plus 6, what's that? 24. All right, there we go. Now we're good. Equal sign. 24 minus 4, that's a 20. And when I distribute this negative, that's going to turn that into a positive. So I'm going to write this one first, guys, so it's easy to see. Because if not, you might not see it. And then minus 3 ln of 2. Now with these two right here, let me do it in green. I'm going to factor out a 3. So I'm going to write 20 plus 3, factor out, and I'm going to write ln of 6 minus ln of 2. And sure enough, look, it's a property there. So I can do, I'm going to write it right here, guys. So 20 plus 3 ln of 6 over 2. Make sure that's both on the inside. So my final answer, 20 plus 3 ln, 2 goes into 6 3 times. And there it is. That was kind of fun, guys. I hope you enjoyed that. All right, we're done. No, we're not done. Sorry. I shouldn't have done that. My apologies. Let's go to the next one, example 7, guys. As you can see, hopefully you're having fun with these. And if you're not, because I can already hear some of you saying like, no, we're not having fun. It's all about attitude, guys. Change your attitude and let's have some fun. Because look, you're home. You're doing these awesome notes. Isn't that kind of cool? All right. You can't factor anything out. There's nothing that factors out here, guys. So what I'm going to do is, again, synthetic division, long division. Sorry. X minus 10. This is going to be really fast because this is a linear and going into a linear, dividing into a linear. X times what is 4x? 4. So I put a 4x. I still have that negative 10 there. 4 times negative 10 is a negative 40. And I'm going to put parentheses. I'm going to subtract. The 4x's cancel out. Negative 43 plus 40, that's a negative 3. So 4 minus 3 over x minus 10. So now this guy, I'm going to rewrite it. Integral. Let's see. 4 minus 3 over x minus 10 dx. I guess before I even would have gotten started, guys, I would have made sure that everything's valid first. I have a vertical asymptote at x equals 10, so I should not be integrating where 10 is in between, and it's not. That's 11, and then e squared plus 10 is a number bigger than 11, so we're good. E by the way is like 2 point something, 2.69 I believe, and when you square that, it's like 4, or you know what, I don't have a calculator here, but I can get one real quick. Excuse me. Let's see what e squared is. So e squared is, oh, I was wrong, 7.389, and E is 2.718. All right, I still have my limits because I haven't changed anything. E squared plus 10. So here we go. Antiderivative. Antiderivative of 4 is 4x. Antiderivative of 3 over x minus 10, I put the 3 in the front. ln, absolute value of x minus 10, close it. From 11 to e squared plus 10. I don't see any mistakes yet. Let me know if you find any mistakes. I'm going to go ahead and do upper minus lower now. So big parenthesis, 4 times e squared plus 10, close it, minus 3 ln, and then open absolute value, e squared plus 10 minus 10, so I can already see the 10s are going to cancel there. Close absolute value, close that giant parenthesis. So here's that first parenthesis there, guys. And then minus, now I'm doing the lower. So let's see, 11. 4 times 11 is 44, minus 3 ln, 11 minus 10, and all right, here we go. Side note, ln of 1 is equal to 0. You guys already know that. Right here, 11 minus 10, that is 1. So that goes away because all that is 0. And so now the 10s here cancel out. So it looks like I have 3 ln of e squared, and I can move that to the front. So here's what I now have, guys. This first parenthesis, I'm going to distribute this guy like that. So I have 4e squared plus 40, and I just noticed that I did a color change. My bad, guys. Minus 3 times 2 is 6 ln of e. Now remember, ln of e is 1. And then now that minus 44. So what I have here is, let's see, I have, if I didn't make any mistakes, 40 minus 6, that is 34. 34 minus 44, or that negative 10. So I have 4e squared minus 10. Okay, this was from the second parentheses. I don't see any mistakes. Let me make sure real quick. 40 minus 6 is 34. Yes, and then 34 minus 44, that is negative 10. So yeah, there it is, guys. We're good. All right, let's go to the next one. So this one, I think I made this one up. I just put some random numbers similar to Delta Math, but not quite, because Delta Math was using little decimals here. So let's take antiderivative. Remember again, the derivative of e to the x is e to the x, so the antiderivative of e to the x is e to the x. So I'm going to write itself 10, and I'm going to leave some space here, guys, e to the negative 3x. If I took the derivative of e to the negative 3x, I would have had a negative 3 in the front. I don't, so that means I have to have a negative there and divide it by 3. I guess I don't need the space. I could have just put it in front of that coefficient there. So there it is. That will work. So you can always stop right here. And look, if you take the derivative of this, you get this guy. The derivative of negative 10 over 3 e to the negative 3x is itself, which is all this, times negative 3, which the negative 3's would cancel out, the negative would cancel out, and the 3 would cancel out, and you'll get back your 10. See? So it works, guys. All right, let's put it back. Negative 3. So that's the antiderivative of that, and then minus the antiderivative of 8x is 8x squared divided by 2, so 4x squared. And since I have more than one term, I have two terms, I'm going 0 to 2. So here we go. We're going to have to do both, guys. Some of you guys have been getting lazy and don't try the 0, but the 0 does affect in this one. So let's plug in the 2. So giant parenthesis for the first one, negative 10 over 3. If I plug in a 2, that's e to the negative 6. And then minus, let's see, 2 squared is 4. 4 times 4 is 16. So there it is. Minus, and then let's plug in a 0. E to the 0 is 1. So I'm going to have a negative 10 over 3. And then 4 times 0 is 0. So there it is. And so let's see. I guess what I'm going to do is I'm going to turn that 16 here. I'm going to do a common denominator. So 16 times 3, let's see, 16, 32, 48. So that's 48 over 3. So here we go, guys. Negative 10 over 3, e to the negative 6. I'm going to do something with that e to the negative 6. I'm going to turn it to a positive in a little bit. Minus 48 over 3 plus 10 over 3. So 48 plus 10 is 38. Well, negative 48 plus 10 is negative 38. So what I have is negative 10 over that e to the negative 6. I'm bringing it down. 3e to the 6. So now I turned it into a positive. And then I'm going to write minus 38 over 3. And I don't think that, nope, that does not reduce. I don't see any mistakes. If you find mistakes, guys, let me know. Put it in the comment section and you'll get 5 extra points. All right, let's do this one here. So this one is coming from Delta Math. What I would do before even starting anything, I would rearrange this. Let me put it in blue so we don't confuse it with the one on top. I would rewrite it, guys. I'm going to go integral 0 to 16 2e. Then negative 0.25 is the same thing as saying negative 1/4 x. Negative 1/4 x minus 2. Okay, I think it's easier now, in my opinion. So let's see. The derivative, the antiderivative, well, the derivative of 2e to the negative 1/4 x is itself times negative 1/4. So we're going to have to do the opposite, right? So let's see. I'm going to write 2e to the negative 1/4 x. And I'm going to multiply this by negative 4. So if I do that, let's see, and I'm going to go, the antiderivative of 2 is just 2x. 0 to 16. And it works, guys, because then I'll have a negative 8 e to the negative 1/4 x. And if I take the derivative of that, I'll have a 2, because 8 divided by negative 8 divided by negative 1/4, or divided by negative 8 times a negative 1/4 will give me a positive 2. So it works. So now I'm doing upper minus lower. Sorry that I got tongue twisted there, guys. This is all first time doing it here, and I'm not going to edit the video. I just want to get this video out the way here so you guys can have an awesome education. So let's see. I guess I should have rewritten it first. Let me rewrite it one more time. Bracket negative 8 e to the negative 1/4 x minus 2x and 0 to 16. So let's do upper and lower. So I'm going to write giant parenthesis, negative 8 e, and I'm going to plug in 16 in there. 16 divided by 4 is 4. So negative 4 minus 16 times 2 is 32. 32 minus, open parenthesis, if I plug in a 0, e to the 0 is 1 times negative 8, so negative 8. And then 2 times 0 is 0, so there it is. So then I have negative 8 e to the negative 4 minus 32 plus 8. So when I do that, let's see, 32, 22, 24. Negative 8 e to the negative 4 minus 24. And I think we're good, guys. Maybe you want to factor out a negative 8, but I wouldn't. I'd leave it right there. All right. Average value. Remember how we find average of anything, guys. I always remember it with velocity. Average velocity is equal to distance, or displacement, sorry, divided by time, or the change in time. Well, it so happens that in calculus, we find the displacement by doing the integral of velocity. And then the distance in time, if I call this A and B, 1 over B minus A. And there it is. That's the same thing, guys. These are the same. I hope you can see it. This right here is displacement. And then this is like dividing by B minus A. So it's the same thing as saying all this divided by B minus A. But instead of writing it like this, you put the B minus A here in the front. And it's the same. So what I'm trying to say is that we have a nice formula. Average value of f is 1 over b minus a, integral from a to b of f of x dx. All right, let's do it. I want the average value of this. I can't factor anything out on the bottom, so I'm going to write average of f is equal to 1 over 7 minus 1, integral 1 to 7 of 12 over 4x minus 3. So we get 1 over 6, and then times 12 ln absolute value, or you don't need it because the 1 and the 7 is always going to be positive, 4x minus 3, and then, hold on, if I were to take the derivative of ln 4x minus 3, I would be multiplying by 4, but I'm not, so I have to divide that by 4. And 1 to 7. We probably could have done u sub on this. I think this would have been a good one for u sub, but that's fine. No big deal. 12 divided by 4, 4 goes into 12, 4, 8, 12, 3 times. So, and then the 3 over 6 is a half. So here we go, guys. 1/2, and I'm doing upper minus lower. The half is factored out, and I'm going to plug in a 7 there. So ln, and then 4 times 7, 7, 14, 28. 28 minus 3 is 25. Minus ln, if I plug in a 1, 4 minus 3 is a 1. And then ln of 1 is 0. So there it is. 1/2 ln of 25. I don't see any mistakes. Let me know if I confused you guys. This one would have been an okay candidate for u sub, I think. All right. Again, we have pi to the x over 2, so there's an exponential. So I'm going to do a side note so no one gets confused here. I don't think we need to break it up into two integrals. I think we'll be fine. D dx of a to the power u is a to the u ln of a du dx. That's your chain rule. All right, I notice I have pi. I'm going to rewrite it. Pi, and I'm going to write it like this, guys. 1/2 x plus 3, and I'm going to write that one. I'm going to bring it up. This is not 3 ln of x squared. This is not a linear term in the bottom, in the denominator. So I'm going to write it as 3x to the negative 2. Okay, here we go, guys. So derivative of a to the u is a to the u ln of a. So the antiderivative of a constant to the half x has to be itself. Pi to the half x. Are we following me so far, guys? Now, I should have an ln pi in the front, and I do not have an ln pi in the front of this integrand. So that means that I have to be dividing by ln pi to cancel the ln pi that would have been in the front, guys. So we're just doing balancing. It's just a balancing thing here. Now notice I still have this du dx. I have a half x. The derivative of half x is, why doesn't this thing work? There we go. The derivative of half x would have been a half. So I would have said times half, but there's no half here. So that means there has to be a 2 right there in the front. The reciprocal, whatever the reciprocal is in front of that half x term, the coefficient there. And yeah, so there it is. That's the antiderivative of the pi 1/2 x. We're not done. We're not done. So in case you're thinking like, oh, we're done. No, like we're not. We're not. Antiderivative of this guy, so that's going to be, let's see, plus 3x to the negative 1 divided by negative 1. And then you got to put the plus c. So now let's write everything nice and neat. 2 over ln of pi, all that's a constant there. Pi to the 1/2 x minus 3 over x plus c. Now, some of you probably aren't convinced about this one on the side, guys. So you don't. If you're done, just go ahead and fast forward it. But if you don't understand this, then bear with me here a little bit. Let's say I want the derivative of that. Derivative of 2 over ln pi of pi to the 1/2 x. This is a product. So I'm using this rule right here. So according to that rule, I'm going to leave my constant alone. 2 over ln pi. And here we go, pi to the 1/2 x. So it says a to the u times pi to the 1/2 x. And then it says ln times ln of pi. So there's that, this guy right here. And then it says du dx, so derivative of the 1/2 x times 1/2. And in case you're wondering, Chavez, how come this 2 over ln pi? Well, that's like a constant. I have it right there in the front. See, so there it is. Okay, so check it out, guys. This half cancels out with that 2. This ln pi cancels out with ln pi in the bottom. And you're just left with pi 1/2 x, which is what I have right there. Perfect. It worked. So when I take the derivative, I better get what I have on the inside. When I do the antiderivative, there it is. My antiderivative is correct. I hope that made sense. If it didn't, we're going to have to talk a bit. All right. So then I put this question in here just so we can make sure that we know what's up. Because, derivative and integrals are like inverses of each other. So here we go, guys. The derivative of ln of 3t is 1 over 3t, times 3. And then I'm still not done. Oh, okay, sorry guys, it's because my Uber Eats order is coming. So, yeah. Okay. Anyways, I'm still not done. I have to take the derivative of pi to the t. Now, that's just this, guys. So I'm going to write ddt of pi to the t is itself pi to the t. So do not bring the t down. I know several of you that have done that mistake over and over again. ln of pi times the derivative of t with respect to t, which is just 1. So there it is. So I'm going to write that down here. So I'm going to put plus pi to the t ln of pi. And that's it. You're done, guys. I guess the 3's cancel out. So maybe you should write it like this. 1 over t plus pi to the t ln of pi. All right, let's keep going. So I have this guy here. So now this guy, let's see, 1 plus 2x, linear, nothing in the top, constant, perfect. So I don't think I have to do anything fancy here, guys. That's just going to be ln, absolute value. There's no limits. So I'm going to write 1 plus 2x, close it. Now, if I would have taken the derivative of this, I would have had a 2 in the front. I don't have a 2 in the front, so I have to put a half. Does that make sense? Okay, I heard some yeses. And then plus, Chavez, what do I do? Relax, e is a constant. So this, you can add 1 and divide by that number. X to the e plus 1, because e is a constant, divided by e plus 1, and then plus c. because there's no limits. Now, some of you are probably saying, Chavez, I don't get it. How come when you did something to the power x, like 5 to the power x, you didn't do that? Well, because I'm being raised to the power x. This one's being raised to the power e. X was a variable. E is a constant. It's like x squared. Antiderivative of x squared is x to the third over 3, because I add 1 to that exponent and then divide by that number. It's the same thing, guys. X to the e plus 1 divided by e plus 1. I hope that made sense. All right, this one we're going to have to talk a little bit about. I would probably put this one or do this one in 2. So I would probably do this first. I would probably go integral of 1 over 9 plus 3t. And I would probably do that on the side first. And then I'm going to do this in blue. I'm going to color code them. And this one in red. All right, so here we go. The first thing I would do, I notice that's a 9 and I notice that's a 3. I can factor out a 3, guys. Integral 1, 3, parenthesis 9. Oh, I just said I factored out a 3 and I didn't even factor it out. 3 plus t dt. Now that I factored that out, I can write 1/3 in the front, integral of 1 over 3 plus t dt. And you're ready. So the antiderivative of that, I'm just doing that part right there, guys. The antiderivative of that, 1/3 ln, absolute value, 3 plus t, close it. And then, of course, it's a plus c. That's just for that one. Now let's do the blue. So I'm going to do integral, I'm going to put it up here, of pi to the 2t dt. Well, antiderivative is itself pi to the 2t. And then I don't have an ln of pi in the front, so obviously I'm dividing by ln of pi. And then when I would have taken the derivative of 2t, I would have had a 2 in the front, but I don't have a 2 in the front, so that means there has to be a 2 in the bottom. And there it is, guys, plus c, of course. And if I take the derivative of this, if you want to check it, if I were to take the derivative of this guy, so let's see, let me put everything that's a constant here. 1 over 2 ln of pi times pi to the 2t. This is in the side, ddt. So let's see, leave the constant alone, 1 over 2 ln of pi, and then times, and then pi to the 2t, ln of pi times 2. Yep, the 2 cancels out with this 2, ln of pi cancels out, because that's in the top. Ln of pi cancels out with that ln of pi. So sorry guys, I ran out of real estate, but yeah, it works. So sorry if I confused you, I hope I didn't. Please, please, please look at your notes of how to take derivative of exponentials. All right, so let's put them together, guys. I'm gonna do it in black. So putting them together, so integral of 1 over 9 plus 3t plus pi to the 2t. We only need one c when we do this, so there's no reason to add both of these, just have one of them. So 1/3 ln, absolute value, 3 plus t, close it, plus pi to the 2t all over 2 ln of pi plus c. Oh, just in time, guys. Bell just rang. All right, you guys are dismissed. Come back in 20 minutes. I'm kidding. I'm not funny today. I apologize. All right, guys. Take care of my assignment. You have till Wednesday. I think that's more than enough time. I may have a new video tomorrow. I may not. I'm not sure yet. It depends on several things that are going on at the moment, several factors. Sorry if I seemed a little down. I'll be back up by the end of the week, promise. And be safe, guys. I heart you guys. You know, I don't want anything to happen to you guys. And so stay safe, be good, and I guess I'll see you when I see you guys. All right, take it easy, guys, and talk to you guys later. Bye.